chapter in the user authentication about FIDO2. The floor is yours.
Thank you, Robert. So the official title of this presentation was a bit longer. It was this future without passwords and the future without phishing, and what to do with this new thing called FIDO, how to deploy it on a corporate level. But I decided to, in the last minute, to make it more poetic. And but I promised that the subjects, the topics I've promised are in this presentation. So let's start. 2 years ago, Google introduced these little security keys to its all 89,000 employees, and they have completely neutralized phishing. Since the employment, they have reported no account takeover. And account takeover, as we are all familiar, it's a major pain. It's a major component of almost every security breach that is out there. Good afternoon, everyone. My name is Marcin. I'm the CTO and co-founder of Secfense. It's a company that helps other companies save time and money while improving their overall security strategy related to user authentication and authorization. But why have I started with Google in the first place? It is because that event, the deployment of these FIDO2 keys in Google, inside Google, was not only a huge thing for Google itself, it was a tremendous step forward for the entire internet security and the user authentication in particular. And let me tell you why. In 2013, Google joined the already existing alliance called FIDO. And these guys were thinking about this industry standard that was built around public key cryptography that would eradicate passwords completely. And at the same time, Google in their own house, they've been doing the very similar thing with the guys from Yubico and NXP. But they've been working on this open second-factor authentication standard, again revolving around public key cryptography. So they have decided to join forces, and Google made a lot of contribution to the entire standard. So first of all, they've provided the entire specification, so the whole blueprint on how things should work. Step two, they've enabled their devices. So Google has a huge potential when it comes to consumer devices. So they've provided native support for Google Chrome and Android OS. So like more than 2 billion devices were instantly available were actually ready for the standard. And the Chrome OS, a Chrome browser, a major browser in the market, it was instantly activated. So it was huge contribution by Google. But the most significant contribution by Google was the battle testing of the solution on themselves. So that's the case I was referring to in the beginning. So they actually proved that the standard is working, it makes them secure, and it actually works. And you need to bear in mind that Google's entire infrastructure is not hidden behind any sort of VPN. It's like completely open on the internet, available on the internet. Their zero trust security model forced them to change the access controls, to shift the access controls from the network perimeter to the individual users. And in other words, they have to have trust in the authentication mechanisms. And they proved that the standard works and is ready. So the alliance, the initial FIDO alliance has grew in size over the years. It's currently 260 members and growing, including the biggest names on the tech and not only tech market. So there's Microsoft, there's Samsung, Nokia, it doesn't matter. There's Visa, MasterCard, Bank of America, you can see the names. So there's these huge guys working on the open standard. The authentication is being liberated. The authentication mechanisms are being liberated. And all these guys are contributing. Google made a huge contribution in the beginning, but these guys are contributing constantly. And the initial specification, this universal second factor, was provided by Google. It evolved to the bigger picture. It evolved to the bigger project. FIDO2 is the umbrella So it's not only a multi-factor authentication built on PKI, but it's also a passwordless experience when the authenticators are biometric. So things have been changing, evolving, but the mission remained the same: to use local authenticators and public key cryptography as a mean of authenticating users on the web. And so these are like few samples of how these authenticators look like. I've seen here there's a Yubico, one of the major manufacturers of these keys, and Google with its program. But thanks to the standard is open, so actually anyone can produce these authenticators. So you can. It's up to you if you want to trust the Swedes or the Chinese, or depending on your level of paranoia, you can build your own keys because of the standard. Actually, these two guys at the top, the key in the white coat, and this naked guy, they are actually the examples of open hardware built by some smart individuals. As long as they comply with the standard, they do the job. And these form a group of these roaming authenticators, so or cross-device authenticators. So you can imagine that you can have a single key that can be used independently on the devices and can generate and authenticate your identities on the web. Which is something which is what is obvious is that they have this USB interface, but most of these keys are also capable of NFC communication over the radio. And there's just one example of the Bluetooth one. The Bluetooth is not very popular. The Yubico guys have given up the support because of the security considerations. But the NFC and the USB are hardly put in the specification, and they do the job. So I will show you just a few clips in a second, but there's another group of authenticators. Actually, this is what FIDO2 is evolving to. So it seems like these cross-device authenticators, these keys, are something or some sort of a transition towards the local authenticators. If you can think of these fingerprint sensors or the infrared cameras capable of facial verification, everything that you can think of that would unlock your device can be now, thanks to FIDO, used to generate and then authenticate identities on the web. And I will show you a few clips on how these different factors in different situations work. So this is a typical scenario with a USB-enabled key. The key is in the port, it's just flashing, and the identity got generated. And that was too fast, so I don't know how to play it again, so I'll skip that. This is the example of the NFC communication. So we have a smartphone with NFC capability, and just tapping the key would generate the identity. And again, authenticating the identity looks the same. The third example would be, I will be using the local authenticator, the fingerprint sensor that was enabled by Google thanks to Android OS to be working with FIDO2. So the ceremony is the same. The user, there's small user interaction, just tapping on the key or tapping on the sensor, and that's it. And so that's the fourth example, and the last one where there's a computer involved. So this MacBook Pro has fingerprint sensor built in, and again, it was how identities got generated and how they get authenticated. But what just happened here? There were two processes. The one was when identity got generated, and the other when the identity was authenticated. So during generation, there was the service, the website, asked the authenticator to mint a pair of security keys, of public key cryptography-based keys. And after human consent, it was always a human consent, physical exercise, either touching the button or touching the sensor. The public key has been released to the service. And again, when the user was trying to authenticate, there was a randomly generated number being sent across to the same key, and again, after human consent, only this particular key or this particular authenticator was capable of responding correctly. And everything, yeah, I'll just skip it back. Everything that's been done, which is very important to FIDO, was done within the scope of a particular application, which means that this particular service was blind to any other identities that was generated by the key. And from the other side, the key could have been generating hundreds or thousands of identities, and they will never be linked. There's this privacy rule that the user cannot be tracked by the identities that he generates. And I think the most important thing is that the communication could not be performed during the phishing attack, because the entire communication is done within the scope. I will show you the difference. So this is a typical, maybe now typical, but it was not typical some time ago, attack on an end user. It's a phishing attack with a real-time proxy in between. There's an evil actor that tricked user to click the malicious link. The domain, the domain could have been less obvious, but imagine there is just a small typo in the domain. The user is actually tricked in this case. So there is a real communication between the user and Google. So this is not like rendered. It's a real-time communication with the evil proxy in between. The user is providing password, but his account is protected with SMS-based tokens. So he's providing the token that was sent to his device, and he hopes to be secure, and he's finally logged in. But at the same time, the attacker not only intercepted his password, which is nothing unusual for the phishing attack, but he also gathered all the session that was done by the user. So now the attacker is replicating the cookies that's been gathered from the proxy and is replicating the victim's session. So even though the user authenticated with SMS-based one-time password, he got compromised. And this is a problem. This is actually the very reason Google abandoned TOTP. They've actually used this one-time password generated on a smartphone, but this attack can be done on any TOTP-based method. And there is another example. This account is protected by FIDO key. So the user is typing his login, and he's giving his passwords. Obviously, in this attack, he would lose that password. But look what's happening. The communication just got stopped because the identity that he generated was generated in a scope of Google.com domain. And this domain is slightly different. And thanks to this native support in that browser, the communication just dropped. So even if the user is really willing to give up his identity to the attacker, there's no way to do it with FIDO. And so the FIDO2, this set of technologies between browsers and authenticators and services, it's built on three pillars, three foundations. So security, privacy, and convenience. So security means that each identity is securely generated cryptographically on a device. It never leaves the device. It never shares any secrets, unlike the TOTP-based method. So there's nothing to be stolen by the attacker if he compromises the service, unlike TOTP or passwords. There's a human consent. The user has to push the button in order to proceed with the communication. Even if the machine is infected with malware, there's no way to force this communication without human physical presence. Privacy. Identities are isolated. There is no way to track identities across services. So you can have a single key or a single authenticator that is used to protect your social account, your social media account, to your bank, or corporate account. They can never be linked back. The authenticators, they do not share IDs. So there is no way to track users by the usage of the key. They only share an ID of a batch. The batch cannot be smaller than 100,000 devices. So this is very privacy-oriented standard. So everything, all building blocks are already in place. If you are tech giants in Silicon Valley, they already you upgrade their applications. They already use the consumer-facing products, and there's actually in most of them there is already FIDO2 enabled. If you are a developer, you can take the specification, upgrade your application, and have it done. No problem. You can ask your users to opt in, so they can do this secure authentication. If you are a Google and you're swimming with cash and you have infinite budget on cybersecurity and the total control over your infrastructure, you can do it. You can upgrade every piece of your tech stack, and you're ready to go. If you are a typical, well-established, mature, yet not pure technology company, and you have probably hundreds or thousands of web applications and administrative panels, certain firmwares that are not being able to be upgraded, you're in a completely different situation. You have this heterogeneous environment that is really difficult to be treated in a unified way. So you probably have certain applications being protected by, I don't know, RSA tokens or SMS-based passwords, or you can even have the legacy PKI infrastructure or partially deployed SSO strategy. But you know that your entire infrastructure, most of your infrastructure, is left with password-only default. And this is actually where we can help with Secfense. We've developed a technology that is built, that is spread entirely on the organization's infrastructure, and is providing things like multi-factor authentication or microauthorization, I'll be talking later, in transit. So there is no need to be updating these applications, but we can do it live. And so it doesn't matter that the application is an administrative panel provided by one vendor or the custom-tailored application built internally. It just doesn't matter. We do not modify applications. We just put ourselves in a position where we can observe, analyze, and modify traffic to these applications. And yeah, FIDO2, so we can enable FIDO2 in minutes. And a picture is worth 1,000 words, so let me show you something. So this is a typical web applications with the password default. So the users log in with passwords only, and obviously this makes them vulnerable to a variety of attacks, leading to account takeover. And let's change that with Secfense. So let's assume Secfense is already run in the organization. And we've created this representation of this application inside Secfense. So that was just step one. There are 3 steps that needs to be done. In step 1, we create this virtual host inside Secfense. In step 2, we do it's a one-time process. It's a learning phase. So Secfense will try to figure out how this application is built without knowing the technical details underneath. So we don't know the tech stack behind this app. We only observe the network traffic and how the application changes on the front end in the DOM. So it's obviously no such user exists in the target app, but that was sufficient for Secfense to be gathering data. So once Secfense is fed with data, we apply that knowledge. And you can see that as a default method, we've set to FIDO U2F, currently FIDO2, and look what's happening. The same user that used to log in with password only would now be required to provide an extra factor of security. So that's exactly the same key that Google uses within their own infrastructure. So by being in this position of a broker, we can add these applications in minutes. It's not a matter of few months long projects. There's no software development. There's no third-party code that is residing in your applications, and there is no vendor lock. We can liberate you from vendor lock if you wish. But being in a position, we've figured out that there is something else we can do. There are certain actions, there are certain areas in applications where you would like your user to reassure you that there's still this user behind the keyboard, that this is not like a malware control machine or an automated attack. So we thought we can do it. And so this is like an example of certain resource that we would like to protect with more care. This is a very simple example of revealing contact. But you can imagine that it could have been a medical record of a patient, or it could have been a detail of a contract, or some personal data. And you want your users to be certain that they really want to do that action, and you want them to re-authenticate. So we describe that resource in Secfense. It's a matter of few minutes. I've skipped that on the video, but trust me, it's just a few minutes of describing the resource, and once this protective layer is in place, look how the experience changes. So if the user is trying to access that resource, he instantly is requested to tap on the security key. So even if his session was hijacked somehow, there's no way to get to this resource. The attacker could have been doing math in this, how to say, somewhere in the application, but not in this resource. And these actions are obviously logged and then can be examined for possible malicious usage. And we can extend that. So let's imagine you want your supervisor to be authorizing such requests. And it's again that easy, like changing one option in Secfense. And this time, if the user is trying to use his own security key, that would not be sufficient. So this time, no. And so this time he has to come get his supervisor and ask him to use his security key. And this time it should do. And yeah, and that's Secfense in a nutshell. So we can provide these protective layers for any web application in minutes. And we believe that in a world where multi-factor authentication is becoming a must due to either internal awareness or external regulations like GDPR or PSD2, and especially with this evolving environment, rapidly evolving environment, we can play a great role in securing environments. And I encourage you guys to give us a chance and do a proof of concept with us. The deployment is very, very easy, very straightforward. It's unobtrusive. We require just an hour of your network guy, and if you don't like it, the rollback is even easier. And that's all I have for today. Thank you very much for your attention, and hope to see you at our booth. Thank you very much.